Alright guys, today we're going to learn about the interior angles sum theorem. To learn about that, we're going to look through a few cases below, and we're going to see that the sum of the degrees in any polygon can be determined by the number of triangles that can be drawn within the polygon, right? If we know that a triangle sums to 180 degrees, then however many triangles can be formed within inside of the polygon, we can just double or triple or quadruple that value. So let's take a look and see if we can find any sort of pattern that occurs in this table, and then come up with a formula that we could use for any case. All right, so we have a triangle, right? That's a three-sided figure. The number of triangles in the picture, there's one, so that would be 180 degrees total. Then we have a quadrilateral. Notice if you split a quadrilateral with this diagonal, we have two triangles, right? So a quadrilateral is a four-sided figure, but there's two triangles created inside of it. So that would be 180 plus 180. So quadrilaterals sum to 360 degrees. They're interior angles, which kind of makes sense, right? 90, 90, 90, 90, all add up to 360. Then we move into a pentagon, which has 5 sides. Okay, notice if you just start from this vertex and you connect vertices to all the other non-adjacent vertices, we're creating 1, 2, 3 triangles. Okay, so that would be 180 times 3, which would give us 540 degrees. And let's keep going. Now we have a hexagon. A hexagon is a 6-sided polygon. If you start from this vertex and draw a line to every non-adjacent vertex, we create 1, 2, 3, 4 different triangles. So we can take 180 degrees, multiply it by 4 triangles, and that would be 720 degrees for the sum of all the interior angles in a hexagon. Then we move to an octagon. An octagon is an 8-sided figure. We're going to go ahead and start to take just any vertex. Maybe I'll pick this vertex and create triangles by drawing a line going to every non-adjacent vertex. And let's see what we get. So it looks like we have 1, 2, 3, 4, 5, 6 triangles that are formed. So 6 times 180 would give us 1,080 degrees. Okay, then we have a nonagon, which is a 9-sided figure, and a decagon, which is a 10-sided figure. Now, instead of sitting here and drawing all those lines, let's see if we can come up with some sort of pattern in the table, right? When we were dealing with a 3-sided figure, there's just one triangle. When we're dealing with a 4-sided figure, there's just 2 triangles. Dealing with a 5-sided figure, there's 3 triangles. So I'm kind of noticing a pattern here. If you take the number of sides and you subtract 2, right? The number of sides, subtract 2. Number of sides, subtract 2. Right? And that pattern holds all the way down the table. Right? If you take the number of sides, subtract 2, that gives you the number of triangles that you're working with. So I'm going to let n represent the number of sides in a polygon. We know that we're going to take n, we are going to subtract 2, and this is going to give us the total number of triangles that are inside the polygon. The last thing that we would do is take this value and multiply it by 180 degrees, right? So this is really the formula that we've just come up with by looking at the patterns inside of the table. So let's use this formula to go ahead and solve the last 2 cases. All right, so basically if we take a nonagon which has 9 sides, we're going to take the 9 sides, subtract 2, and we're going to multiply that by 180. So 9 minus 2 is 7, times 180 is giving us 1,260 degrees. Okay, I'm going to take a decagon which has 10 sides. I'm going to take the number of sides minus 2. Right, that'll represent how many triangles there are. So that would be 8 times 180, so 1,440 degrees for that one. So let's just formally generalize that relationship below, right? This is going to be the sum of interior angles formula. Okay, so I would probably put that on a note card. And let's make sure we're studying that note card. But if n represents the number of sides, like we discussed earlier, then the sum of the interior angles S can be found using the following formula. So the sum of the interior angles is equal to the number of sides minus 2. Okay, that gives you the number of triangles. Number of triangles. And then you take the number of triangles and you multiply it by 180 degrees. Okay, the next formula that we're going to look at is the interior angle. Notice that's not plural, it's just the interior angle of a regular polygon. Now, if we want to talk about the definition of a regular polygon, let's just go ahead and write that down below. A regular polygon is a polygon where all sides and all angles are congruent. So a very famous example of a regular polygon that you guys are aware of would be a square, right? Square, all the sides are congruent, all of the angles are congruent. But then you can have like a regular pentagon, okay? And a regular pentagon means all of the angles are congruent and all of the sides are congruent. Well, if all of the angles are congruent, right, then we can take the total sum of the interior angles and just divide that by the number of sides. So a regular polygon is one in which all the sides are equal, therefore all of the angles are equal. To find the measure of the interior angle of a regular polygon, we're just going to take this formula and divide it into n equal parts. So n minus 2 times 180 divided by the total number of sides. All right, go ahead and flip when you're ready. And again, make sure that you make a note card of these two cases. So let's look at some practice problems. We're going to find the sum of the interior angles of a 15-gon. That just means a polygon with 15 sides. So we know that the sum is equal to the number of sides, right, which the number of sides in this case is 15, minus 2 times 180 degrees. So we have 15 minus 2, which that gives us 13, times 180 gives us 2,340 degrees. All right, here's another case where we're finding the sum of the interior angles. So the sum is equal to the number of sides, which in this case we have a 21-gon, minus 2 times 180 degrees. So 21 minus 2 will leave us with 19. Times 180 gives us 3,420 degrees. Okay, and then the last question in this section is a little bit different. It says, what's the measure of each interior angle of a regular pentagon? So first we're going to find how many degrees a regular pentagon, the interior angles, add up to be, and then we'll divide that into 5 equal parts. Excuse me. Okay, so we can take 5 sides minus 2 times 180, and we're going to divide that into 5 equal angles. So 5 minus 2, that's 3 times 180 is 540, and 540 divided by 5 leaves us with 108 degrees for each interior angle. All right, now let's talk about the exterior angle sum. So we talked about interior, but now we are talking about exterior. Exterior angles are always supplementary, right, sum to 180 degrees to their adjacent interior angle. On the polygons below, we're going to find the measure of each exterior angle along with the sum of all the exterior angles. Okay, so we have a good example of a linear pair right here, right? A linear pair are two angles that are adjacent and they add up to 180. So if I do 180 minus 61, that's going to leave us with 119 degrees right here. All right, same idea with this one. I'm going to find that exterior angle. If I take 180 and I subtract 79, that leaves me with 101 degrees. And last linear pair to consider, if I take 180 and I subtract 40, that's going to leave us with 140 degrees for this angle. All right, so it says now let's find the sum. So we have 140 plus 101 plus 119, and that gives us a total of 360 degrees. Okay, let's look at the next case. Let's go ahead and find all of the missing pieces of the linear pairs. So we have 180 minus 89. We have 180 minus 71. We have, 180 minus 124. And we have 180 minus 76. Okay, let's add up all four exterior angles. We have 109 plus 56 plus 104 plus 91. And that gives us, again, 360 degrees. Now, just to save time on this video, if you don't believe me, you're more than welcome to go ahead and work these out, but we're going to see that the sum of the exterior angles always adds up to 360 degrees. This will always be the case. So that's probably the last note card that I would make, is that the exterior angles are always going to sum to 360 degrees. So we'll do a few practice problems. What's the measure of each angle in each exterior angle in a regular hexagon? Okay, so we're going to take 360 degrees, right? We know the total number of degrees added up is 360, right, for any polygon. But if we divide that into 6 equal parts, okay, then it looks like all of those would be 60 degrees in that case. What's the measure of each exterior angle of a regular 24gon? Right, so again, we know that all the exterior angles in any figure add up to 360 degrees. So if we divide that into 24 equal parts, and again, the reason why I know they're equal parts is because it's a regular polygon. So 360 divided by 24 gives us 15 degrees. And let's see, last problem. If the exterior angles of a regular polygon measure 12 degrees, how many sides does the polygon have? Okay, so essentially we were taking 360 and dividing it by n, right, the number of sides, to get what each exterior angle is. So what we're going to do, well, I'll write out the entire formula, right? 360 divided by the number of sides was equal to a regular polygon. All right, so that's my formula. So we're going to kind of work backwards. We're going to do 360 divided by, I don't know what the number of sides are, but I do know that it came to give us 12 degrees. So we can multiply by n on both sides, right? Times n times n. That would cancel here, leaving you with 360 is equal to 12n. Last up, I can divide by 12 on both sides. So 360 divided by 12 would give us 30. So it looks like the number of sides, this would be a 30gon in this particular case. All right, feel free to rewatch the video or go back to any parts of this, but make those note cards today and go ahead and get started on your homework once you've shown Miss Miller and Coach Price that you've completed your notes. Thanks.